On this assignment, we'll be talking about the standard normal curve. I've got a picture of it here. The standard normal curve works with z-scores. A z-score of 0 means that you're average, right at the mean. And then a z-score of 1 means that you're 1 standard deviation above the mean. A z-score of 2 is 2 standard deviations above the mean. A z-score of -1 is 1 standard deviation below the mean. We talk about areas, probabilities, the probability that you are between, to the left, to the right. Things you need to know about the area under this curve, the area of the standard normal, is that it's always 1, always 100%. We will use the table, the standard normal cumulative probability table found in your book and on a handout. The probability table gives the z-scores on the sides and the top and the probabilities in the middle. Those probabilities are always from the z-score to the left. I always draw the picture when I'm doing these, even when I don't. I need that visual, and most students do too. Number 1, the probability that you are between a z-score of 0 and 1.77. So find the z-score from your table of 0 and find the probability. That's 0.5. We know that because we know that this whole thing has a probability of 1 or 100%, so half of it from 0 to the left is going to be 0.5 or 50%. The probability that corresponds with the z-score of 1.77 from my table is 0.9616. So the area from 0 to the left, that's this, is 0.5. And the area from 1.77 to the left, this, is 0.9616. So to find the area of the blue, we take the orange area, 0.9616, and subtract off the pink area, 0.5. Number 2, to the left of z equals -0.75. -0.75 is about here, and we want the area to the left of it. Our table gives the area to the left, so we just look up a z-score of -0.75 and find the area, 0.2266, or 22.66%. The area between the z-score of 1.23, that's about here, and 1.9, that's about here. When you're looking between, you want to subtract the probabilities. So use your table. The probability that you're to the left of 1.23 is 0.8907. The probability that you're to the left of 1.90 is 0.9731. 13, sorry. So to find the area in between there, you subtract. .0806, or about 8%. Always use your common sense checker. You drew the picture, right? Does this look like it's about 8%? Yeah. If you'd have gotten 80%, you'd say, wait a second, that has to be wrong. There's no way that that little shaded area is 80%. Between 0.24 and -1.12. Since it's between, I will find the probabilities that go with each z-score using my table. So that number right there, 0.5948, that's saying that from this z-score, 0.24, to the left all the way is about 59%. this number that I get from my table is saying that the probability that I'm to the left of this z-score is about 13%. So I take this one minus this one. To the left of z equals 1.31. 1.31 is about here. To the left of it. That's what my table gives me, so I just look that up in the table. Number 6, to the right of z equals negative 1.92. So the z-scores are on the bottom. Negative 1.92 is about here. So I want to the right. Now you have to be careful here, because remember that your table gives the probability that it's to the left. But we know that this whole thing is 100%. So if we want to the right, we just find the table value. And then we know that that is this area to the left. Since we want the area to the right, we know the whole thing is 1. So we just do 1 minus. And that will give us the area to the right. To the left of z equals negative 2.15, so that's right here, to the left of that, and to the right of 1.62. We're looking at the two tails. We're going to have to do two different calculations. The first one, to the left of z equals negative 2.15, I just read the number right from the table, because that is the probability that you're to the left of that z-score. The number from the table here, though, is the probability that you're to the left of that z-score. We want the right, so we're going to do 1 minus that. So this probability corresponds with this area, and this probability corresponds with this area. So I will add them together to get the total probability of being in those two areas. Number 8. First problem is how to read this. This says the probability that the z-score is greater than 0.82, or the probability that the z-score is to the right of 0.82. Greater than is to the right. So 0.82, that's about here. Probability that your z-score would be greater than that, to the right. Our table gives the probability that you're to the left, so we're going to have to do 1 minus the probability that we get from our table. .2061, or 20.61%. That's the probability that you are in that region. So what does this statement say? It says the probability that your z-scores are between negative 0.2 and 1.56. So negative 0.2 is about here. 1.56 about here. So what's the probability that our z-scores are in between those two values? Since it's in between, you find the probabilities that go with each one of these z-scores. And subtract them. Number 10, the probability that the z-scores are between 1.12 and 1.43. 1.12 is about there. 1.43 is about here. My picture's maybe not quite accurate. It's a really skinny little area there we're looking at. So I'm going to find, when we do between, we find the probabilities and subtract them. Before we start this problem, let's talk a little bit more about our table, the standard normal cumulative probability table. The numbers on the outsides, those are your z-scores. The numbers that are on the insides, those are the probability. Those probabilities correspond with the probability that you will be to the left of any z-score given. So it's all the way to the left, which is why I'm going to actually start with number 13. Because they show me a z-score here. I can kind of estimate it by looking. And then they give me the probability that I'm to the left of that z-score. Well, that's good for us because that's what our table shows, the z-score all the way to the left. So all I do is go to my table and look around in the middle at the probabilities for a probability of 0.9671. And I find it. It corresponds with a z-score of 1.84. So that's the answer. That's the easiest one, and the reason why is because you're looking at the area that's to the left of the z-score. Okay, here you have the area to the right of that z-score. Well, that's fine, except for our table gives to the left. So we need to figure out what would this area to the left be. So we just do 1 minus, because we know the whole thing's 1 minus so we know that the area to the left of this z-score is 0.9761. That's what our table shows. So now we can go to our table. Go to your table, find 0.9671 in the middle, in the probabilities. Find the z-score that aligns with that. 1.98. So the z-score that corresponds with the probability shown here is 1.98. And you can kind of see that by looking. Number 11. We want the z-score that corresponds with this probability from 0 to 1 point something. The probability is 0.4066. But the problem is our table doesn't give from the z-score to 0. It gives from the z-score all the way to the left. So our table is going to correspond with that value. Can we figure out what that value would be? Well, yeah, you just take this area, 0.4066, and add 0.5 to it. So we know that this half is 0.5. So now we can use our table because we know that the probability that you are to the left of this z-score is this probability, and that's what our table gives. So go to your table, look in the middle numbers, the probabilities for 0.9066, and find the corresponding z-score. Again, check for reasonableness. Does that look like about 1.32? Sure. So we've got it. Find the z value, the z-score, to the right of the mean so that 54.78% of the area under the distribution curve lies to the left of it. Okay, first let's look at the words left and right in here. First, this, right of the mean. All that's telling us is that all of our z-scores are going to be on this side, positive z-scores. They're to the right of the mean. They're above the mean. We want 54.78% of the area under the curve to be to the left of this z-score we're going to find. So 54.78% of the area. Well, we know that half is 50%. So we're probably not looking at a number that's very far over the halfway mark. Probably, I'm going to estimate it right in there. So we're looking at the z-score that gives us that much area. First thing, change this to a decimal. Then, what is this? This is a probability. So when we go to our table, where are the probabilities found? In the middle. So we're going to find 0.5478 in the middle numbers and find the z-score that corresponds to that. The z-score that corresponds to that is 0.12, which makes sense. That looks like it could be about 0.12. Same thing, 69.85%. Well, let's see, halfway is 50%, so a little bit more. We want that area. Change it to a decimal because our table uses decimal places, uses decimals. And then search the middle of the table for the probability 0.6985 and look for the corresponding z-score. .52. And that makes sense. 88% of the area. It's going to be a little more. We're looking for the z-score that gives us approximately that picture. Change your percent to a decimal. Go to your table, look at the inside of the table for the probability 0.8810. Find the z-score that gives you that probability. The z-scores will be along the outside. A z-score of 1.18 gives us a probability of 0.8810 to the left of the curve.